You're asked to find the inverse and graph both the original function without restrictions and its inverse. So first of all, to find the inverse here, I'm going to switch the x and the y values and then solve for y. So subtract 2 from both sides to get x minus 2 equals y minus 5 squared. Take the square root of both sides to get square root of x minus 2 equals y minus 5, and now add 5 to both sides. So my inverse function here is going to be the square root of x minus 2 plus 5. So there's my inverse. When I'm looking for graphing the quadratic, this parabola here, basically it's a standard parabola, no a or b value, but it's going to go 5 units to the right, 1, 2, 3, 4, 5, and 2 units up. So I'm first moving the vertex. And then since there's no a or b value, my reference points 1 over and 1 up, 2 over and 4 up, both are staying the same. And so here is my parabola. Now when I'm graphing the inverse, remember with the inverse, I do need a restriction because in this one here, I'm basically just looking at 2 to the right and 5 up, 1, 2, 3, 4, 5. I could graph it with the transformations, or I could think, I know that this point here, the vertex of my parabola is at 5, 2. So I know my starting point for my inverse is just going to flip those two around, which becomes 2, 5, which is my purple point right there. Now everything else, again, with a square root function, we're taking this point here and flipping that one. So that would be 6, 3 becomes 3, 6. And this point here, which is, it's like 7, 4, 5, 6, becomes 6, 7. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and 7. And there is the inverse. The domain restriction that we needed for that was we took all of the x values that were greater than or equal to 1, 2, 3, 4, and the h value, which is 5.